Did you know that Earth's rotation is gradually slowing down? Now, don't go panicking and throwing your watches out the window. It's not quite as dramatic as it sounds. You see, our planet, this spinning marvel we call home, is actually losing speed at a snail's pace. To give you a rough idea, Earth's rotation is slowing down by approximately 17 milliseconds per 100 years. I know, it hardly seems worth mentioning, right? But bear with me. This slight deceleration means that days were actually shorter in the past. Now, I'm not talking about the good old days when we were kids and summer vacations seemed to last forever. I'm referring to a time long, long ago when our ancestors were still trying to figure out which end of the spear was the pointy one. The cause behind this cosmic tardiness is nothing other than our faithful lunar companion, the moon. It's all about gravitational interaction, my friends. You see, the moon's gravity pulls at the Earth, causing a slight bulge. This bulge then acts a bit like a brake, slowing down Earth's rotation. It's a bit like trying to spin a basketball with a lump of clay stuck on one side. And just to add a dash of irony to the mix, as Earth's rotation slows, the moon is gradually moving away from us. About 1.5 inches each year, to be exact. So not only are our days getting longer, but our nights are getting a little less bright too. Now, before you start worrying about days that last forever and a moonless night sky, let me reassure you. These changes are happening so slowly, they're unlikely to affect us or even our great, well, you get the idea, grandchildren. So, in essence, our days are getting just a tiny bit longer each year. And who knows? Maybe one day we'll all appreciate a few extra moments of daylight. You might be wondering, what could a few milliseconds possibly matter? Well, when it comes to our dear planet Earth, they matter a lot. The Earth's rotation isn't as steady as we might think. In fact, it's slowing down, and this has some pretty intriguing implications. Imagine a spinning top. As it loses momentum, it begins to wobble and spin more slowly. The Earth, like a gigantic top, is also gradually slowing down. Now, don't get too alarmed. We're talking about a decrease of just a couple of milliseconds per century. It's not like we'll wake up tomorrow with days suddenly twice as long. But over millions of years, this slowing rotation will add up, resulting in longer days and nights. Now you might be thinking, great, more time to binge watch my favorite shows. But this shift could have a profound impact on our climate and ecosystems. Today, the rapid rotation of the Earth helps distribute solar heat evenly around the globe. But as the Earth's rotation slows, this heat distribution might become less efficient. This could lead to more drastic temperature differences between the day and the night, between the equator and the poles. And what about our ecosystems? Many plants and animals have evolved to thrive in our current 24-hour day-night cycle. A change in this cycle could disrupt their routines, potentially leading to significant shifts in ecosystems. Even our technology could be affected. GPS systems, for instance, rely on precise time measurements that are tied to the Earth's rotation. A change in the Earth's rotation could therefore require adjustments in these systems. So while a few milliseconds might not seem like much over long periods of time, they can add up to significant changes. It's a reminder that even the smallest details of our planet's behavior can have a profound impact on life as we know it. It's fascinating, isn't it? A tiny change in Earth's rotation could have such a significant impact on our lives. The spinning marvel that is Earth continues to amaze and challenge us with its dynamic nature. Now let's talk about a curious concept, the leap second. Have you ever wished for more time? Well, every now and then your wish is granted in the form of a leap second. This is an extra second that is occasionally added to Coordinated Universal Time, or UTC, to keep it close to the mean solar time, or what we often call sun time. But why do we need this extra second? Well, it's all down to the Earth's rotation. You see, the Earth doesn't spin perfectly. It's a bit like a top that's starting to wobble as it slows down. This wobble means that the time it takes for the Earth to complete a full rotation isn't always the same. It's gradually getting slower due to factors like the moon's gravitational pull and the Earth's molten core. This slowdown is incredibly tiny. We're talking about less than 0.02 of a second per day. But these fractions of a second can add up. Over a year, they can amount to nearly a full second. And that's where the leap second comes in. About once every 1.5 years, the world's timekeepers add an extra second to the end of a day. This second is our leap second. It's like a mini time correction, ensuring our clocks stay in sync with the Earth's slightly erratic dance around the sun. You won't notice this extra second in your day-to-day life. It doesn't mean you get an extra second to sleep in, unfortunately. But this tiny adjustment is vital to keep our global systems running smoothly. From satellites to communication networks, they all rely on precise timekeeping. So the next time you're wishing for more time, remember the leap second, a tiny gift from the universe, keeping us in tune with our wobbling world. So while our clocks may not show it, our days are actually getting just a bit longer each year. Now let's go back in time about 70 million years to the age of the dinosaurs. Picture a world populated with these majestic creatures, from the towering Brachiosaurus to the swift Velociraptor. But there's something else that was quite different during the dinosaur era: the length of a day. Yes, you heard that right. The day was shorter in the time of the dinosaurs. How do we know this? Well, the answer lies in the growth rings of fossilized corals and mollusks. Much like the annual rings of a tree, these marine organisms have daily growth rings. By counting these rings, scientists can determine the number of days in a year during different periods of Earth's history. These fossilized timekeepers suggest that back in the dinosaur era, a year had more days, meaning each day was shorter. This evidence indicates that the length of a day has increased by about 7 hours over the past 600 million years. Now you might be wondering, why was the day shorter? That's because Earth was spinning faster on its axis. Over time, due to gravitational interactions primarily with the moon, our planet's rotation has gradually slowed down, making our days longer. Imagine that. A day in the time of the T-Rex was about only 17 hours long, not the 24 we're accustomed to today. That's a whole 7 hours less to hunt, eat, and, well, avoid being eaten. So what does this mean for us? Well, while we often wish for more hours in our day to get everything done, we should probably thank our lucky stars we're not living in the dinosaur era. Think about it. Fewer hours in the day would mean less time for everything we love doing. So the next time you wish for more hours in the day, remember that you're already getting more than the dinosaurs did. Now let's look to the future. What will happen as Earth's rotation continues to slow? As we journey forward in time, our spinning globe will keep on turning, albeit at a slower pace. This deceleration, while seemingly innocuous, could have large-scale implications for life as we know it. Imagine a world where days are longer than our current 24 hours. That's right, the Earth's deceleration will eventually extend our day-night cycle. You might be thinking, great, more time to binge-watch my favorite shows. But remember, every action has an equal and opposite reaction. Longer days would mean longer nights, which could significantly affect our sleep cycles, agriculture, and even wildlife behavior. But that's not all. This rotational slowdown could also trigger shifts in our climate. As the Earth spins, it creates a centrifugal force that slightly flattens the planet and causes the equator to bulge. Should the Earth's rotation slow, this bulge would decrease, redistributing the planet's mass and potentially altering ocean currents and wind patterns. This could result in drastic climatic changes, from increased temperatures to more frequent natural disasters. One more thing to consider is Earth's magnetic field. This invisible shield, generated by our planet's rotation, protects us from harmful solar radiation. A slower rotation might weaken this field, making us more susceptible to solar flares and potentially disrupting our technological systems. So the future of Earth's rotation holds a lot more than just longer days. It's a domino effect that could alter the very fabric of our lives. But before you start panicking, let me reassure you, these changes are expected to occur over billions of years. That's right, billions with a B. So, while it's fascinating to ponder these potential future scenarios, it's not something that should keep you up at night. So, here's a thought-provoking question to leave you with. If you could control Earth's rotation, would you speed it up, slow it down, or leave it just as it is?